So welcome back to Project Redline. Today we're going to do a fabrication episode, which means if you want to know who the best fabricators in the world are, just look at the comment section below. Okay, so if you're familiar with Project Redline, you'll understand that we've gone from a full Bridgeport engine to a semi-PP. Now, if you're new to rotaries and you don't know what that is, click the link below. There's a link to a video we done on everything you need to know about rotary porting, so check that one out after this video to get up to speed. Now, in terms of what that means for us is we've actually had to change the intake manifold to suit this semi-PP engine. We sourced that from South Coast Rotary. However, that means we've got to run different intake piping and a few other things. So I've had to fabricate up some stuff, glue some metal together. We'll look at that in a second. I've also wasn't quite happy with the oil pan. So I originally built it and it only actually had about 3.9 litre capacity. So it was a bit light on. I really want to add about another litre and a half and maybe put a baffle in there somewhere. So we'll cover that as well. But yeah, eventually we'll get all this powder coated too. So I've got something pretty funky prepared for the color. So stick around to the end and we'll reveal that then. But for now, let's get fabricating. Gonna start work on the rest of the intercooler piping. So this is a donut. It's for really tight radius bends. What we'll do is we'll weld a couple of tacks on the inside here. We'll weld most of the way around there, and then we just chop it up to where we need. And the reason we're doing that is we obviously need to make new intercooler piping. So with the new semi-PP engine, the power seal semi-PP intake manifold that we'll have there, we'll run the factory FD top, and then I've just made this adapter already, roughly. That's just a step down adapter that I've bent to shape, and it's just a flange that I cut out. Just need to obviously finish the work on this because it just obviously there's a lip there, so just need to diagram that, but that's all been TIG welded up. That'll go on there, and then just need to come out of here on real tight 90, and then we'll probably have an angle down and then just run into here. Alright, so I am by far and away not an Instagram spec welder. I would class my welding as serviceable, i.e. it does the job I need it to do, which is gluing stuff together. With that being said, I mean, I've welded up now an intake manifold, which was totally fine, the exhaust manifold, the intercooler, what else? All intercooler piping, the wheelie bars, the chromoly rear suspension arms, the upper and lower control arms, transmission mounts, engine mounts, sump, you know, just about everything on this car. You know, modified all the cast water pump assembly and stuff like that. So everything from thin aluminium to thick steel and chromoly, and the car's got 940s, 147. It's been fine, there's been no leaks, nothing's broken, nothing's blowing up. So that to me doesn't matter what your welds look like, if the product is serviceable, and it clearly is, that's good enough for me. So I don't think that the welding that I do is the worst welding, but you'll never see me posting something with the hashtag weld porn, because those guys do it all day every day, and I seldom weld really. When I do, I mean, welding is really a technique where the more you do it, the better you are at it. So I don't do it enough to be a great welder, but I consider myself good enough to make car parts that stand up to what they need to stand up to. So without further ado, let's get into welding this donut. I don't have any acetone, but most important thing with welding, of any kind of welding, is surface prep. So I'm just going to use some of this wax and grease remover because it'll do the same thing, which is remove a bit of the contaminants from the area. Okay, so as self-confessed non-expert welder, I'm loath to give advice on any welding stuff, because everyone knows the people in the YouTube comments are the experts at everything. But for welding, I was getting a bit annoyed with my good old Chinese spec TIG welder here, in that I only have one machine, instead of, you know, it'd be really great if I had two machines, one for DC and one for AC. And I was just looking for, because I do so little fabrication, I was chopping and changing between aluminium and steel quite a lot, which is quite easy on the machine. It's just a flick of the switch. However, originally what everyone had told me was, okay, you can see the little color on the back of what's called the tungsten. This is the tungsten, this piece of metal here, the color there. So people had originally told me when I first started welding that you need the red one for steel and a white one for aluminium. And the more I sort of read up on that, I looked and I found these blue ones, which there says 2% lanthanated right there. And I've actually been using these ones for both aluminium and steel for quite some time now, and I've been pretty happy with the results. So I'm not sure what you guys use out there. There's like all the colors of the rainbow in this, and it's tungsten with a whole heap of different percentage compositions to make it do things differently and react differently, especially with different metals. So I don't know what you guys use. Maybe put in the comments what you're using for aluminium and steel. I know there's one thing I definitely want to do. This is, I mean, just a cheap Chinese torch, whatever that means, WP26 things to style. I did have a gas lens for it, but kept on breaking them, so I need to get something to hold the TIG torch here. I need to upgrade the gas lens, so I don't know what's the best one out there or what ones are a bit more robust. This number 8 cup will be okay, but the better gas coverage you have, especially with a TIG welder, the much better job and you'll end up doing. So, alright, time to fire up the welder and I'll give you a look at some of the settings and we'll see how we go. Now I've got the machine set on AC, TIG, not going to use pulse, and what I'm going to do is I'm going to set the current to about 63 for now, and then I'll just assess it there once a bit of heat, because this is actually cold, so I could actually put some temperature into this and start at a lower current, but I'll just start cold and just see how we go with 73 and then just adjust the current based on there. I really should be using a pedal and probably dialing the pulse, but I've just become really comfortable using this specific machine because this is a cheaper Chinese spec eBay machine. It's not great. It does the job it needs to do, but it's not great with some of the other control functions that some better welders would be. So I didn't like the Chinese, the pedal that it come with too, and I bought a different pedal as well, and that was pretty crap. And I've just felt I've had much better control just using it like this. So we'll see how we go with this, and then yeah, we can just adjust the machine settings from there. Don't have any gloves on. Did have some TIG welding gloves, but I don't know where they are now. So this tip isn't sharpened either. So let me just do that first, which just helps control the arc really. Otherwise it might wander a bit. You know, we know exactly where we want to stick the arc, so to speak. So I'm going to be able to control that. So for me, not being an expert welder, pretty much the only thing I can recommend to you is get comfortable. At the moment, you've got plenty of this cord to play with, and what I do is I'll get a fair piece of it and I'll just sort of almost lay it in my lap, like so, which takes a lot of the weight off the torch, but still gives you good flexibility. So just essentially, I mean, welding is, you've got to be comfortable doing it. So I'll spend a couple of minutes often just playing around with how I like the torch set up before I actually do any welding, and I might reposition this piece a fair few times before I do anything as well, because again, comfort is everything. The more comfortable you are at doing it in the right place, the better your end result will be, because you're not sort of fighting everything. So I just noticed now that this ground cable is routed. What is up with that? Hopefully it doesn't flash any arc across it, but whatever. Let's put that up there. Just another thing to add to the pile of welding equipment that I need. Alright, no guts, no glory. Let's see how we go. Another tack over here. Few dabs there, and I'm quickly going to get to the point where I can't wear gloves again. So I'm just moving around, tacking it at a lot of places all the way around, because I don't have any pressure on this, but if I was just to weld off that side, what you'd notice is that this side would just lift all the way up. So I just want to make sure that it's still nice and closed, so I don't have to put a clamp or any other kind of apparatus on it to hold it in place. At least if I know now, without any heat in it, it's going to remain where it needs to be, so I'll just keep going. Maybe I'll try and cheat, be a tight ass here. What do you reckon? I reckon that's the epitome of being a massive tight ass. Right, so before we get started tonight, have a look at what I just spotted in Bunnings on my way home. I was going to pick up some more recip saw blades, and I spotted these ones. This is pretty cool. So you can see normally in a recip saw blade, you can see where the wear is here. I mean, you've got a big blade like this, but generally a lot of the wear occurs just in this area. Now this blade from Irwin, you can see here it says 1 and 2. Now the idea behind this is obviously your blade goes in here. You wear away what you normally wear away at the start of the blade. You then snap it here at this point, and then you've got another blade again to wear. So yeah, you put this in here as we do, wear away all this area here where they normally wear away, snap it, and then you've got a whole new blade, and all you've had to do is buy, essentially you just buy one blade. So you get obviously like way more life out of them, because they're not just, you know, you're not just using, you're paying for a whole blade normally, you're only using this little bit and then you're throwing them away. But these blades look pretty cool, and have a look at that, made in the USA as well. So I'm really keen to try these out. They're multi-pitch too, so 14-18, so they'll be good for steel as well as aluminium, which is what we have to cut now. We have to cut our donut up, so I'll give these a whirl on them now. But this is that's pretty cool technology. So after cutting some bits and pieces out, this is the giant sort of Meccano set you're left with. And essentially just have to now tack all these pieces together and number them. You can see there I put a 1 and 2. I've got 2 dashes there. What I've found sometimes through experience, if you just put a line here and then a single line there, you get over to the bench and lo and behold, you forget which way this bend goes, because it's very, very similar in dimension and size and angle. So I always put a 1 or a number them or 2 dashes or whatever, but we can take this apart now, finally tack it up, and then we'll whack it back on, and hopefully that's the last trial fit, and then we can weld the whole piece up. So you can see here where the donuts are welded on the outside and the little tacks on the inside, and that's just some straight pipe there as well. And then we've got the quick release couplers there as well. Makes it easy if we, you know, for whatever reason we want to take the pipe off, but yeah, there'll be plenty of access here for spark plugs and whatnot anyway. So alright, let's get welding this. Alright, so it's pretty much job done. So as you can see, pipe all done. I'll have to obviously weld it all up now, but that's pretty much it for all of it. So that's the hardest part. The absolute hardest part is fabricating all this in terms of cutting all the pieces to the right length and whatnot. So now that that's done, the easy part is actually welding it. So weld it all up now, take it apart, test fit it again after it's welding, because, you know, obviously things can change ever so slightly though, with the heat going into it. We should be all good, and then have to weld in another temperature sensor as well as a bung for where we want to put the water injection port. And then besides that, probably just paint it or linish it and polish it, not sure yet. Yeah, but that's it. At least it's that's one major step that we've still got to have to finish, and now we're done. So after I've done this, I'll probably get back into finishing the last little bits of wiring, and then last great piece, which is the engine. So the engine component should be here sometime next week as well, so that'll be great. Get stuck into that, and not a hell of a lot to do after that. What I think I might do with a sump is just put a wing on the front there, because there is limited room with the cross member and stuff. So just to get more capacity, I'll try and get another litre or so in the front, and then I'll just create a wing there. It's going to mean that I won't be able to do the bolts up, you know, to the pan traditionally. So that's pretty easy. I've got some thick alloy bar here, so what I'll do is I'll cut these to length, mill a hole straight through the middle of them, and then those lengths I'll use between inside the sump essentially. So they'll sit inside the sump, and then I can pass an Allen key bolt all the way through and still bolt them up and then just weld around them inside and out, and they'll be obviously then leak free. Not much left now but to take that pipe off and start welding. So the quicker we get started, the quicker it gets finished. So I'm onto that now. No easy way of doing this except being Hercules. I can't remember how I bloody put it in there now. Did I get in? Maybe I got in. Oh, because these things aren't right. Maybe I did get in. I'll leave my safety boots behind. Oh, here I go. Got it? Jesus! Oh, I think I had a piece of cardboard up here too. This will do. This will do. Thank you, Turbo Smart. Oh my God, Jesus Christ! Don't think that's going anywhere, but I'm getting the bloody hell out of here quickly before I give it a chance to. Oh. The fuck did I manage to put a bolt in the most inaccessible place in the whole bloody thing? Alright, so if you didn't understand what I'm already doing, this is the current sump. You can see there it's stepped to clear the cross member, but most of the capacity is in this part here, so it's just not big enough essentially. So what's happening is I don't have any gates or hinges or anything in here to stop the oil flow back, other than there is a fairly decent step up, but it's just obviously not big enough, and the volume in here is not big enough is the main issue. So what I'm going to do is cut the front off here, so cut all this front section off and just weld another box essentially extension on the front of that. That should give me hopefully another litre and a half, which will give this total sump capacity pretty close to 6 litres then, which I think will fix all my problems. So time to get underway and cutting. One big giant hole cut in the front of it. We'll extend a box out here, and for these bolts we'll weld essentially big posts here, here, here and here, which will be hollow. We'll weld around there, come up to here, drill through the base of it, also weld there. So here's the workings behind what I want to do. I've got a 1 litre bottle here. I've pretty much fit it in the space, and I can see that that's very similar to the dimensions that I want for about the capacity. And now it's just a case of cutting it all to size, so let's do it. Okay, so after a little bit of measuring and cutting and folding, you end up with something like this. So that will just sit in there basically after we trim it and cut it all to shape. All I've got to do now is drill 1, 2, 3, 4 holes all the way through here and all the way through to the bottom, and then weld. So we'll weld them on here first so they're sealed, and then I'll drill a big hole here so that it basically fits over like a sleeve, and then I'll weld up the top as well. Alright, so these are the posts I'm going to make. They'll sit in between here, and we'll drill holes all the way through. Alright, easy as that. Very repeatable too. So you can see they're exactly the same heights, perfectly straight as well, which is great compared to if you just use a recip saw. You might, be on the piss a bit when you're cutting it. So what we're doing here is turning these this solid rod into basically tube, and the way we go about doing that is whacking it here in the middle. So just use vice jaws there to hold it, to hold the round bar concentric. It sits up against the base here. I've got my depth gauge set it here from 100. I know they're 90mm thick, so once I get down to 10, I know I'm all the way through. These aren't precision machined or anything, so I'm not bothering with doing them in the lathe. I could do them in there as well. All I've got to do is drill a hole somewhere in the middle, not even concentrically exactly in the middle, just somewhere in the middle all the way through, and then it's done. Because all I really want is a 6mm hole in the middle of it to fit a 6mm thread Allen key bolt for the sump. So this is the next step. So all we've got to do now is put a bit of that on there just to get started, and away we go. As you get deeper and deeper in the hole, it is a good idea to raise the drill bit in and out, and that just helps clear the hole, because this is a blind hole, so it hasn't been drilled all the way through yet. So that means that a lot of the chips and the debris that's in here is staying in there, and some of it may not get ejected out of the flute. So just as you're drilling down, just bring the drill bit up, and it will just eject those chips. Should hear it. Pitch of the drill sound soon, the noise it makes as it goes through to the end. 2 down, 2 to go. Okay, so here we are, time for the big reveal, and the secret colour we went with is gloss black. What a shock to match everything else that's gloss black on our car. Wow. Couldn't see that one coming, but it's the easiest colour to hide dirt and junk and that, and it looks nice. You know, we might paint the engine a different color when we're done. That'll be coming up in the next one, but here's everything we've done. So Suba Design down in Bayswater, just down the road. I needed a new powder coater because of where we've moved to, and the guys down there did an absolutely bang up job making my absolutely terrible welds look great. I mean, we've only been voted the 987th best YouTube channel regarding welding, so we've got a long way to go, voted by the people in the comment section. So, but this is all, I mean, it all worked fine previously, so you know, I'm not really concerned about what they've got to say, to be honest. You can see that, so the throttle bar you normally go here. This is a plate I made just out of plate steel, just some pipe bent up into shape, and then we've got a quick disconnect fitting there. This is the standard FD intake manifold. This is the semi-PP manifold from South Coast Rotary. So all this normally was just cast aluminium, and Super Design down in Bayswater have powder coated this black. Now this is some kind of petrol resistant super gloss black that they found just for this. So special thanks to those guys. Go check them out where you can, because they did a bang up job. Last part here, you can see our intercooler piping, and there's some stuff you probably might recognize, there's some stuff you might not. So this is a Gen 5. No, actually it's a Gen V. Oh wait, no, whatever the comment section want to decide to rag us out on this time. So Gen 5 V Design Raceport Turbo Smart blow off valve with this sensor in the top. We've got a secondary, so the pipe actually runs sort of this way on the car. So this is another air temp sensor. So we actually have one in the intake manifold, but this will be measuring intake air charge temperature directly out of the intercooler. Looking to also run one probably out of just after the turbo, before the intercooler, so it can measure temp there. But the reason this is here is because of these two nozzles here. So this is actually set up for water injection. We'll run over that in a bit more detail in a later episode. The reason why you can see some alloy here and some not is because this is actually tape all around here. So just one of those, I covered the bungs up in totally with tape around, so that's why they're looking like that. You can just see the edge on the tape there actually. So these are just water injection nozzles. So you can see there the little tiny outlet there. So fine atomized pressurized water, or in our case it would be methanol, comes out of there. It gets introduced into the intake system, and this joins up to here, into the intake, and then into the engine to cool down the intake port charge. So I've always been very interested to see what water injection can do, especially on an alcohol-based fuel. So E85, people traditionally think great detonation, suppression. Why would you run methanol or water injection? Well, I'm really looking to run a lot of boost on this thing now, and I'm not so sure the Chinese intercooler is doing a great job, to be honest. So it'd just be good data. The fuel tech's got more than enough inputs to track all that type of stuff. So yeah, it'll be interesting to see how that goes. The last part, just a quick look. I haven't painted it or actually completely finished this yet, but this is just the sump in almost its finished form. And you can see here we added the whole great big section there to it. I haven't machined down any of this yet, but these are the bosses, so you can still obviously fasten the sump to the plate. So that's all sealed up. That gives me about another extra 1.5 litre capacity, which takes the capacity close to about, I think it's about 5.5 litres, which is great. And I also added a baffle about here, which you can't see inside of it. So that means when all the bulk of the oil is here and the pickup is also here, and when the car launches on off the trans brake, hopefully the oil tries to rush back and it hits that baffle, and it won't actually rush back into this area, which is, I wasn't seeing low oil pressure, but I was seeing a slight drop off in oil pressure on the trans brake launch. So hopefully that fixes that. Bearings come out of the engine all looking fine, so I know there definitely was no oil pressure problem. I just saw it on the data logger, which is why data is so important. But yeah, in terms of fabrication, that's pretty much it for now. So before we can put this all together in the car, we need to build the engine. So there's some machine work to come. We've got a machine for some studs on the new semi-PP housings, and we're going to stud the whole engine, because before, as you'll see in the teardown video on a previous video, there was actually only one down the engine. So we'll plan to build that engine shortly. So we'll run you through the whole process of studding an engine with 1/2 inch studs, and maybe clean up the factory exhaust ports. And yeah, that'll be on the next episode, and then we can get it all in the car and get down to the racetrack. So thanks for joining us today. If you like this episode, consider subscribing to the channel, ring the bell so you keep up to date with all the notifications. Give us a thumbs up if you like the contents, and yeah, until next time, I'll see you later. Thanks for joining us.
And like always, support the people who support us.